Welcome to lesson 2.1, chapter unit 2. So brand new lesson, brand new unit, brand new lesson, log logic. Okay, let's kind of just dive into it, into our ready problems. So graph each function over the domain between -4 and +4. So what that means is that we only care what is happening. What is happening? We only care what is going on, what is going on between -4 and 4, inclusive, right? Like including them. Okay. I think the best way to do this is to make a table. Okay, I want to make a table of values for x and 2 to the x, right? This is my y. So x and y. Okay. I only care about -4, -3, -2, -1, 0, 1, 2, 3, and 4. I'm going to do something very direct here, and I'm just going to plug it in. And you should be able to do this by hand, right? No graphing calculators. So I'm going to go 2 to the power of -4 is equal to 1 over 2 to the 4, right? This is a property of exponents that we should be able to be familiarized with, right? And we can rewrite this as 1 over 2 to the 4, right? So let's kind of talk about our powers, and you should be able to calculate these out, right? Or kind of know them out by memory to some extent. I'll stop here. Yeah, so 2 to the 4 is 16. And then I get 2 to the -3. So that's equal to 1 over 2 to the +3, which is just 1/8. And then 2 to the -2 is 1 over 2 squared, which is 1/4. 2 to the -1 is 1 over 2 to the 1, just 1/2. 2 to the 0 is just going to be equal to 1. 2 to the 1 is 2. 4, 8, and 16. Right? Now, I have my values of x. I have my values of y. So all we're going to do now is plot points, right? So let's go to our table. At -4, I am at 1 over 16. So that's like really small there. Okay? At -3, I'm at 1/8, so a little bit higher. At -2, I'm at 1/4, so definitely a little bit more high. And then -1, I'm at 1/2, so just halfway there. At 0, I'm at 1, so that's our first kind of concrete point. At 2, I'm at 4, plotting that right there. At 3, no, at 1. Why am I skipping points? At 1, I'm at 2. So right there's 2. At 2, I'm at 4. So this is 1, 2, 3, 4. And at 2, I'm at 4. So right there. At 3, I'm at 8. Right? We'll call this 8. And at 4, I'm at 16. So right up. Okay? Now what we do now is we just connect these points as best as possible. Oh my goodness, that was crazy, right? I'm going to connect these points. Perfect, okay? I only care about -4 to +4, right? So technically I went a little bit over here. Perfect, okay? I only care about -4 to +4. That's all I care about, okay? Now, okay, cool. So for number 1, that's kind of what it should look like, okay? Now for number 2, we have the 2 times 2 to the x, okay? So there is a vertical transformation there, right? I am multiplying this by 2, okay? So what does that mean? Okay, so it means that whatever I got from my 2 to the x, I'm going to multiply those values by 2, okay? So I'm going to essentially going to keep x here, and this would be y is equal to 2 times 2 to the x. keep my same x values, 0, 1, 2, 3, 4. Now I'm gonna cheat a little bit, and what I mean by that is that I'm going to take these values that I found already and multiply them by 2, right? So I'm going to get 2 times 1 over 16. That's equal to 2 over 16, which is just 1 over 8. And I'm going to get here 2. I'm just going on my pencil. I'm going to get 2 times, I'm cheating, right? I'm using the top ones because we did that work, right? So 1 over 8 is equal to 1/4. 2 times, I'm cheating again, 1/4 is equal to 1/2, and then 2 times the 1/2 is equal to 1 here. Okay, now I'm doing 2. I don't have to cheat so much anymore. This would be 2, right? I'm doing 2 times 2 to the 1, which would be 4. 2 times 2 squared, so that would be 8. 2 times 2 cubed is equal to 16, and then 2 to the 2 to the 4, I will put as at 32. Okay. So yes, I cheated, right? I used the values that we had found already. Okay. Now plugging in points. So at -4, I'm at 1/8, so a little bit bigger. At -3, I'm at 1/4. So actually, let's do a little lower. 1/4. At -2, I'm at 1/2. At -1, I'm at 1. So this is my first concrete point. At 0, I'm at 2. Okay, so that's important. 0, I'm at 2. At 1, I'm at 4. So 1, 4. 2, comma 8. So 2, 8 is there. And then 3, 16. 3, 16. Okay, 1, 2, 3. And then at 4, I'm at 32. So a little bit odd, right? Because 4 is going to be like somewhere away. So I don't even know why they made us do that. It's okay. We'll connect these dots as best as possible. We are back to connecting dots and something like that. Okay, pretend that's more perfect than it is. Okay, so again, to reiterate, what I've been doing is I'm making a table of values. Okay, I'm not using a calculator for this. I recommend that you check your work with the calculator so you can check work on calculator, but you should be fluent without a calculator. Okay, cool. Now let's talk about number 3. So number 3, we have a 1/2 to the x. So things are changing now, right? So we're no longer going to be able to cheat, right? Because now we have to come up with a new table of values. Okay, this is x. This is 1/2 to the x. Okay, I go from -4, -3, -2, -1, 0, 1, 2, 3, and 4. Okay, now let's do this. Okay, I'm going to have 1/2 to the -4 power. Okay. Okay. So I'm going to rewrite this as 1 over 1/2 to the 4th. Okay. That's essentially it. This is the trick, right? You treat the 1/2 as an actual whole number, right? Not a fraction, but it's still basically legal. Okay. Now let's write up our powers. So 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. 1/2 squared is 1/4. 1/2 cubed is 1/8. And then 1/2 to the fourth is 1 over 16. Okay, where am I getting these numbers from? Okay, I'm not just pulling them out of a hat, right? So let's talk about 1/2 to the fourth is equal to 1 to the fourth over 2 to the fourth. Okay, I know that 1 times 1 times 1 times 1 times 1 to the million will always be 1. So in this case, it's just 1. 2 to the 4. Now I can cheat a little. I can go back here and say 2 to the 4. What was 2 to the 4? 16, right? We got it from here. So 16. Okay, so that's what it is here. So I'm left with 1 over 16, which is equal to 16. Okay, so let's kind of chug this all together and think about, well, I can't do this to save my life, right? Okay, it equals 16. Let's move on, and hopefully we kind of get the gist of what we're doing. This is 1 over 1/2 cubed, which is equal to 1 over 1/8, which is equal to 8. Okay, why? So if I have 1, I am dividing 1, dividing this by 1/8 is equivalent to doing 1 times 8, right? Keep, change, flip, which is equal to 8. Okay, so that's where that came from. Now here I have 1/2, to the negative 2 is going to be 1 over 1/2 squared, which is equal to 1 over 1/4 equals to 4. Two, 1. Now we're on more charted territory that we have kind of familiarized ourselves with. 1/2, and then this next one will be 1/4. Now this next one will be 1/8, and then last but not least, 1 over 16. Okay, so at negative 4, I'm way up here now. Isn't that strange? Isn't that interesting? And at negative 3, I'm at 8. I'm going down. Like, I'm decreasing, right? Think about that. The negative 2, 1, 2, I'm at 4 right here. Negative 1, I'm at 2. 0, I'm at 1. So 0, I'm at 1. 1, I'm at 1/2, so right in the middle. 2, I'm 1/4. 3 is 1/8, and then 4 is 1/16. And again, I'm connecting these dots. Okay, I only care about negative 4 to positive 4. Now it should be a little bit interesting to see that what I'm doing here is that it's decreasing, right? And again, there's a big rule. If my we'll call this my base, right? So if my base is greater than 0, so if my b is greater than 0 and then less than 1, I'm going to have this is a decay, right? It's decreasing. Okay. Now we can cheat again, even though cheating is not allowed, right? We don't like cheaters. But in this case, you have to be smart about it. You have to be lazy and use the work you've done before. I'm going to give you that, okay? Mathematicians sometimes can be a little bit lazy, or as I like to call it, intelligent, right? You have to use your past work, okay? I recommend you do that. X, this is 2 to the 1/2 to the x. Same thing, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Why? That's my domain, right? I only care about negative 4 to positive 4. And I'm using those numbers because those are pretty much whole numbers, okay? Now, again, I'm going to cheat. So 2 to the 1/2 to the negative 4 is going to be equal to 2 times my top, which is 16. This is 32. okay? And I'm actually just gonna fill these in. This is 8, it should be 16, 2, 2 to the 4 is 8, and then 2 to the 2 is 4, okay? Now I'm talking about 2 to 1/2 is 0, it'll just be 2. I'm gonna squeeze these down a little bit so I can see better. 2, 1/2 to the 1 is going to be 1. 2 to the 1/2 squared. That's going to be equal to 1/2. And I'm gonna get 2 to the 1/2 cubed. This is 1/4. And then 2 to the 1/2 to the 4th is equal to 1/8. Okay? Let me just verify that that is correct by checking on a calculator, right? Yes, 1/8. Perfect. Cool. Now again, what I'm going to do now is I'm going to plot these points. At -4, I am way up there in the sky. Okay, and don't really, just okay if you don't graph it. -3, I am at +16. So right here is my first point. At -2, I am at +8. So right here. And then at -1, I am at 4. Perfect. 0, I am at 2 now. At 1, I'm at 1. At 2, I am 1/2. 3, I am 1/4. And then 1/8. It just gets smaller and smaller. Let's just kind of pretend that this graph starts here. So down, down, down. No, I'm only going to graph up to there. Okay? Cool. So far, 1 through 4, all we've done is that we've just been graphing, right? Okay, we graphed our functions. Compare problem 1 to problem 2. Okay, so these first ones. Okay. Multiplying by 2 should generate a vertical stretch, okay, of the graph. But the graph looks like it has been translated vertically. How do you explain that? Okay, so, I mean, honestly, it was stretched, essentially, right? It's just all the y outputs were doubled, right? So a vertical stretch this up high, right? So they just appear higher. Doubled, so they appear higher on the graph, which to me, it's essentially a stretch. Okay, I don't really understand what they mean that it was translated vertically. Think about it as like a big kind of like blob, like of like what do I like to call it? Like a big like clay, or like, yeah, and you're stretching clay. You are stretching clay or like dough, like you're making like pizza or whatnot. Okay, higher on the graph. Number 6, compare problems 3 to problem 4. Is your explanation in problem 5 still valid for these two graphs? So take a minute from comparing 3 and 4, right? So yes, it does, right? So yes, it is still valid. Multiplying by 2 will make them appear higher on the graph. Okay. Ready, set. Now we're talking about our set problems. Okay. So given that f of x is equal to 3 to the x, we want to find our inverse. So this is a little bit of a kind of just a overall review. So the inverse the inverse of an exponential function, which is what we are given, is a logarithmic function, right? Is a log function, logarithmic. Okay. So I'm gonna move this up a little bit. Oh, oops, what am I doing? What is going on? Okay. So if f of x is equal to, I'll call this a to the x, then f inverse of x is equal to log of base a of x. Okay? So I think it's important to recognize what my a is, or my base. And I think I'm going to change this to b. I like b better. B for base. Okay? All about that. This is a b. So b, 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 b. Okay? B for base, that's kind of what I'm going to just think about it like that. Base b. Okay? So then here, f inverse of x is going to be equal to just log of base 3 of x. Okay? That's it. This is my base. Okay? This right here and this is right there. Okay? My second one, f inverse of x is equal to log base 7 of x. Right? So 7, this is my base. Okay? This is a little bit more general, right? And this kind of goes back to what I talked about over here, which is funny. I hadn't seen that. F inverse of x is equal to log of just a of x. This is a, this is a. This is a is your base, right? It's a base a. Totally fine. Okay, now we are given the inverse. So we have the inverse. So I want to identify the base. So then f of x is just equal to 10 to the power of x. Okay? So take that a minute. Give that a minute, I mean. So you have the inverse, and you have to realize that the original function, the original function is an exponential function, okay? Now here, f inverse of x for number 11, find your base. So my base here is 27 to the power of x, okay? So given f of x equals 5 to the x, use the table below to fill the missing values and evaluate the log expression. Okay, so I have this table here. Okay, so f inverse of 25. So think about this as x, and this is your y. So then f inverse of 25, this is your y now. So that's equal to 2. 2. And now we want to rewrite this. Well, that's a log expression, right? So I get that log 5 of 25 is equal to 2. I'm talking about this as an inverse. Okay, now here, f inverse of 325, so I care about this number. So log of 3,125 is equal to 5. Okay, so I care about this number and this number so far. Okay, now it's up to us. So these are essentially our y's, and these are our x values, right? Our x. Okay, so f inverse blank equals log 5 blank equals 1. So all this means is that when my x value is 1, I'm asking for the inverse of 5. So f inverse of 5 is log 5 of 5, and that is equal to 1. Okay? Okay. So the connection that I want to make here is that let's think about this. So f of x is equal to 5 to the x. So then f inverse of x is equal to log 5 of x. Okay? So that's why this came from. And if I am talking about f of x was 1, then this would be, yeah, okay. I hope this kind of makes some sense, okay? This is important, right? Because what they're taking you here is that they're giving you the inverse. Now they want you to carry it through and figure out what the value is based off of this, okay? Given that h of x equals 2 to the x and k of x equals to h inverse, right? So this is not -1. This is the inverse. Use the graph of h of x equals 2 to the x to find the missing value in each equation. Okay, so let's kind of just write it out. So if h of x is equal to 2 to the x, then h inverse of x is equal to log of what base? Yes, base 2. Oh, I hope you said that. Of x. Okay, so this is my, and that is equal to k of x. So what am I given? I am given h of x. Okay, cool. So an h inverse of blank equals log 2. That's my base. What is my x value there? 1/2. So at 1/2, right? That is essentially what I'm looking for, right? H inverse of 1/2. So I'm gonna reiterate, copy. Sorry, I only went off on a tangent. Here, right? That this x here is the same x that's here. Okay, so h inverse of 1/2 is equal to log 2 of 1/2, which is going to be equal to -1. Okay, because this is my h of x. This is h of x. Okay, so this is essentially my y coordinate. This is, yeah, my y coordinate of h of x. Here, h inverse of 1, so then h inverse of 1 is equal to log 2 of 1, which is equal. So think about this as change it into an exponential. Well, it's okay. We can talk about this using the graph, right? So at value of 1, that's 0. Okay, so then log 2 of 1 is 0. Okay, because this essentially acts as my y coordinate. This is my y coordinate. (17) Again, this would be 0.25 equals 2. So then I look for 0.25, and I'm right there. That is -2. -2. Okay. And then 18. Answer the question yes or no. If yes, give an example of the answer. If no, explain why not. Does log of x equals 0 have an answer? Okay, so what does this mean? So x of 0. So let's kind of rewrite this as an exponential, right? So as an exponential, log of x of 0 is equal to x to the question mark, which would be equal to 0. But is this ever possible? Can x to the question mark ever be 0? Think about that. So x to any power, would it ever be 0? No. So no. Okay. Log, so log x of 0 does not have an answer. Okay. Ready, set, go. Okay. I hope that kind of made some sense. Please feel free to reach out if anything does not make sense. I want to emphasize the fact that using the inverse means, so inverse, so if this is the function is xy, then the inverse is y comma x. Okay, remember that they flipped. Okay. 27 to the 0 power is just going to be 1, right? Anything to the power of 0 is 1. This is equal to 11 to the 1, which is equal to 11. Okay. This is a little bit different, right? You have negative 1 over 3 squared, which is negative 1, 9. The reason why is not, so there's no parentheses there, right? Like if this, that would have been a different answer. But in this case, this is just, you do, please excuse my dear Aunt Sally, right? So there's no parentheses, there's an exponent there. So that's why you do the exponent first. So you do exponent first. Okay? This is equal to 1 over 4 cubed, which is 1 over 4 times 4 times 4, which is 1 over 64. Okay? This is equal to 9 over, this is an interesting one. So we'll rewrite this as 1 over 2 to the 1. So this is equal to 9 over 1/2, which is going to be equal to 18. Okay? If you have some issues with this, you can kind of see that 9 dividing it by 1/2 is equivalent to doing keep, change the sign, and then flip this, which is equal to 18. Okay, so KCF, Kentucky Chicken Fried. Let's talk about 24. So I have 4 cubed over 1, right? This is just be 1. And then 4 to the cubed is equal to 64. So it's just be 64, right? Okay, so this is big thing. So remember, parentheses, excuse my dear Aunt Sally. But I want us to kind of be a little bit more proactive. I can do this out. I can spend time doing this. But does this matter? But does it matter? I hope that's from a song. But does it matter? No. Why? Because I'm going to take it to the power of 0. Anything to power of 0 will be 1. Okay? So 1. So I'm left with 3 times 1, which is just equal to 3. And this entire blah does not matter. Okay? And that's how people, well, that's how teachers like to get you, right? It could have been something like even simpler. It could have been like 27 divided by 3 to the, I don't know, let's just say a random number like that to the 0, right? Regardless, it would still be 4 because this entire thing would be equal to 1. Okay? Number 26, so I have 3 over 1 over 6 to the 1, okay? Which is equal to 3 over 1/6, which is just equal to 18. Okay, again, this is all about dividing fractions, right? So 3 over 1, dividing it by 1/6, I do my KCF, so I get 3 times 6, which is equal to 18, okay? You can have these over 1, but it doesn't really matter. It's still going to be 18. Last but not least, I get that I like to rewrite these, right? If I have, again, I hope that was clear in the very beginning that if I have 2 to the negative 1 is equal to 1 over 2 to the 1. So same thing here. If I have 32 to the negative 1, it's 1 over 32 to the 1. And if I have 4 to the negative 1 is equal to 1 over 4. So if I'm going to put this all together now, I have 1 over 32. Sorry, that's 3 squared. Over 32. Dividing this by 1 to the 4. Sorry, 1 over 4. Okay, you cannot leave your answer like that. I won't accept it. So you should simplify that further. Okay, so I have 1 over 32, dividing this by 1/4. Again, I'm going to keep, so 1 over 32, flip the sign, well, change the sign, sorry, and then flip. So I'm left with 4 over 32, which is equal to 1 over 8. Okay, and we have, I'm dividing both of these by 4 to simplify it further. Okay, so I get 1/8. I hope all of that made some good sense. I hope you feel ready to move on to lesson 2.2. Okay. So here we graphed using our tables that we did by hand, right? No calculator. You can double check with calculator if your heart desires. Here it's about knowing and understanding that the inverse of an exponential function is the log function. That's crucial to this lesson. And then over here, we did a lot of just exponents, okay? These are just properties of exponents. So I hope you have a great rest of your day.